Hello viewers, you are welcome to this video. Today I want us to look at the remainder and factor theorems. The remainder and factor theorems. First of all, let's look at the remainder theorem. The remainder theorem. Now viewers, I have a video on division of polynomials. Yes, those of you who have not watched that video, you are advised to go and watch it. Yes. Now when you have something like this, when you have a polynomial f of x, we are first of all looking at the remainder theorem. The remainder theorem. The remainder theorem. I want to explain one or two things. Remainder theorem. Now, when you have a polynomial f of x, and this is divided by x minus a, viewers, what you are going to get is known as the quotient plus remainder over divisor. And the divisor, this is the dividend, this is the divisor, in this case is x minus a. Are you seeing it? Yes. So if the remainder is 0, then everything here will go to 0 and then you are going to have the quotient. So the dividend divided by the divisor is equal to quotient. Are you seeing it? Plus remainder over the divisor, this is the divisor. So when the remainder is 0, then this will go to 0, this one will go to 0, and you have this. Now, the remainder theorem, look on the board. Viewers, if you have something like this, if you decide to multiply through by x minus a, then you are going to have f of x. Because x minus a will cancel this one. It's equal to quotient times x minus a. Because you are multiplying through by x minus a. Plus, when you multiply here by x minus a, it will cancel x minus a. So you are going to have remainder. So let me see. Remainder. Now, viewers, look on the board. If you find f of a, that is in place of x, if you decide to put a, then here, when you put a here, this one will be a minus a, and a minus a is 0. So it will cause the whole of this to go to 0, and you are going to have, so it's going to be 0 plus remainder. And this is equal to remainder. Remainder. So f of a will be equal to remainder. Are you seeing it? So what this means is that if a polynomial f of x is divided by x minus a, then f of a will be the remainder. Yes, when you find f of a, that will give you the remainder when the polynomial f of x is divided by x minus a. Now, similarly, if you have a polynomial f of x, let me clean this one, and it is divided by x plus a, then this one will hold. Quotient plus remainder over divisor. Again, if you multiply through by x plus a, then this one will be f of x is equal to quotient times x plus a plus remainder. Because x plus a will cancel x plus a here. Now, if you find f of negative a, then what this means is that wherever you see x, you are writing negative a. And if you put negative a here, this one will be negative a plus a. That will be 0. And that will cause the whole of this to go to 0. And this will be equal to remainder. So what this means is that if f of x is divided by x plus a, then the remainder will be f of negative a. So when you have a polynomial f of x and it is divided by x plus a, then the remainder will be f of negative a. So when you have to find the remainder, you just put negative a in the function, that will give you the remainder. Viewers, this is the remainder theorem. So the remainder theorem states that if f of x is divided by x minus a, then look at it. So if f of x is divided by x minus a, then f of a is the remainder. On the other hand, if f of x is divided by x plus a, then f of negative a is the remainder. So what happens is that if it's x minus a, if the divisor is x minus a, then you just equate it to 0. And x minus a equal to 0, so x is equal to a. So you are going to put a in the function, so f of a. If the divisor is x plus a and you equate it to 0, it will x equal to negative a. So it means that I have to put negative a in the function. That will give you the remainder. So the remainder theorem states that if you have a polynomial f of x and it is divided by x minus a, the remainder will be f of a. On the other hand, if you have a polynomial f of x and it is divided by x plus a, f of negative a will be the remainder. Yes. Okay. So let's look at examples. It's not difficult at all. Let's look at examples. They can give you something like this. Can say that find the remainder when x squared plus 6x minus 9 is divided by x plus 5. Yes, so we can give you something like this. Find the remainder when this is divided by x plus 5. So solution. So viewers, what they have been given is, so just say x plus 5 is equal to 0. X is equal to what? Negative 5. So this is what they have been given. This is what they have been given. So we can just let this one be. So you can see let f of x be equal to x squared plus 6x minus 9. So f of negative 5 will give us the remainder straight away by the remainder theorem. So this one will be negative 5 all squared plus 6 times negative 5 minus 9. Negative 5 squared will be 25. 6 times negative 5 will be negative 30 minus 9. So this one will be 25 minus 30 will be negative 5 minus 9, negative 14. So viewers, this will be the remainder when this polynomial is divided by this divisor. Yes. So those of you avoid the division of polynomials, you can try it. You can divide this one by this and you see that the remainder will be this. Now let's look at another question. Question number 2. You can say find the remainder when x cubed, when f of x, you can say f of x equal to x cubed plus 2x squared plus x minus 4 is divided by say x minus 3. Solution. So you can see x minus 3 is equal to 0. X is equal to 3. Now we have f of x is equal to x cubed plus 2x squared plus x minus 4. So by the remainder theorem, f of 3 should give us the remainder, f of 3. So 3 cubed plus 2 times 3 squared plus 3 minus 4. Wherever you see x, right? Yeah, 3. So this one, 3 cubed is 27. That is 3 times 3 times 3. Plus 3 squared is 9 times 2, 18. Plus 3 minus 4. 27 plus 18 is 45. Plus 3, 48. Minus 4. 44. So viewers, this will be the remainder when this cubic function or this polynomial is divided by x minus 3. Divided by x minus 3. So it is not difficult at all, US. It's not difficult at all. Okay. Now, you can also look at something like this. Number 3, you can say find the remainder when f of x equal to x squared plus 10x plus 25 is divided by x plus 5. So solution x plus 5 is equal to 0, x is equal to -5. This means that f of x, the function is x squared plus 10x plus 25. F of -5 is equal to -5 all squared plus 10 times -5 plus 25. -5 all squared will be 25. 10 times -5 is -50 plus 25. 25 plus 25 is 50 minus 50 is 0. So viewers, here the remainder is 0. Isn't it? If the remainder is 0, it means that this is a factor of this. This is a factor of this. Yes, let's look at the last question under this, and then move on to the factor theorem. The factor theorem. Question number 4. You can say that the polynomial f of x equal to, say, ax squared plus 4x plus 9 leaves a remainder of 2 when divided by, say, x minus 1. But when divided by x minus 1, find the value of a. Find the value of a. Solution. So this is a divisor x minus 1. This is a divisor x minus 1. So x minus 1 is equal to 0. So this implies that x is equal to 1. Now I have been given f of x is equal to ax squared plus 4x plus 9. Now f of 1 is equal to a, wherever you see x, write 1. So a times 1 squared plus 4 times 1 plus 9. And viewers, because they are saying that the remainder is 2, it means that you should equate this one to 2. Do you see? This time around they have given you the remainder and they want you to find the value of a. Are you seeing it? Let me write this 9 well. They have given you the remainder to be 2. So f of 1 should give us 2. So we are going to use that one to find the value of a. Now this implies that this one will be 1 raised to the power 2 will be 1. So this one will be a plus 4 plus 9 is equal to 2. So let's do this one here. A plus this is 13 minus 2 is equal to 0. So a plus 11 is equal to 0. So a is equal to -11. Therefore, the function here, the value of a here will be -11. Yes, so when you put -11 here to be -11x squared plus 4x plus 9. When this is divided by this, you are going to have this as the remainder. Yes, if you like, you can try. And when you put 1 here, you should get 2. Okay, so let's quickly try that one and then you will see that what you have done is correct. Now, if this is divided by this, you want to check our answer. So it means that x minus 1 is equal to 0. So x is equal to 1. You are going to put 1 in this function, in this polynomial, to see if you get 2 as remainder. So f of x will now be negative 11x squared plus 4x plus 9. Isn't it? So f of 1. When you put 1 here, we're going to have this 4x plus 9. No, x is 1, so let me put 1 here plus 9. So this one will be negative 11 plus 4 plus 9. 4 plus 9 is 13 minus 11, 2. So viewers, you can see that this is the remainder. So it means that what you have done is correct. Okay, so this you should be able to solve any question on remainder theorem. Viewers, let's move on to factor theorem. Factor theorem. Factor theorem. These are very, very powerful. Yes, the remainder theorem, the factor theorem, they are powerful theorems. You need to understand. Okay. Now the factor theorem. If you have f of x, if you have a polynomial f of x, and it is divided by x minus a, divided by x minus a this way. Now, if x minus a is a factor of this polynomial, what this means is that the remainder should be 0. Do you see? If x minus a is a factor of this polynomial f of x, then what it means is that you shouldn't get a remainder. The remainder should be 0. So it's going to be like this. It's going to be quotient. This one is equal to quotient. If it is a factor, if x minus a is a factor, then the remainder should be 0. So to be if it is plus remainder over divisor. This is the formula. Now, if the remainder is 0, everything here will go to 0. Do you see it? Yes, if it is a factor. So it means that if it is a factor, if x minus a is a factor of f of x, then from here you can say that f of x over x minus a is equal to quotient. Yes, I want you to understand everything. Do you see it? Because it's a factor, there won't be any remainder. Do you see it? The remainder will be 0, so everything here will go to 0. So this will be the formula. Now, this means that f of x will be equal to quotient if you multiply both sides by x minus a times x minus a. I see. Viewers, let's try to put in a. F of a is equal to, if you put in a, it will make this one a minus a is 0. 0 times quotient will go to 0. I see. Now, viewers, what this means is that if x minus a is a factor of a polynomial f of x, then what it means is that f of a is equal to 0. Yes, if x minus a is a factor of a given polynomial f of x, then f of a is equal to 0. Yes. On the other hand, if f of a is equal to 0, what it means is that x minus a is a factor of that polynomial. I say, when you have a polynomial and then you find f of a and it is 0, then what it means is that x minus a is a factor of that polynomial. Now, let's look at a situation whereby the divisor is s plus a. Now, if the divisor is s plus a, then this one will also be s plus a. Isn't it? That's the divisor. Now, if the divisor s plus a is a factor of the polynomial f of x, then what this means is that the whole of this will go to 0. This is 0, so it will make the whole of it 0. So we're going to have f of x all over s plus a is equal to quotient. So f of x is equal to quotient It's not difficult at all. You just have to understand. X plus a. Now, if you find f of negative a, wherever you see x, you're writing negative a. You put negative a here, this one will be negative a plus a, and that will go to 0. You see, and that will cause the whole of this to go to 0. So it means that f of negative a is equal to 0. Now, what this means is that if x plus a is a factor of a polynomial f of x, then f of negative a is equal to 0. On the other hand, if you have a polynomial f of x and f of negative a is equal to 0, then what it means is that x plus a is a factor of that polynomial. So this is the factor theorem. Yes, this is the factor theorem. So when you have a polynomial f of x and it is exactly divisible by x minus a, what we are saying is that f of a should be equal to 0. On the other hand, if f of a is equal to 0, yes, when you have a polynomial f of x and f of a is equal to 0, then what it means is that x minus a is a factor of that polynomial. Or, in other words, the polynomial is exactly divisible by x minus a. Now, again, when you have a polynomial f of x and it is exactly divisible by x plus a, on the other hand, if x plus a is a factor of a polynomial f of x, what it means is that f of negative a should be equal to 0. Yes, on the other hand, if you have f of negative a equal to 0 when you have a polynomial, what it means is that x plus a is a factor of that polynomial. It's not difficult at all, viewers. You just have to understand. Okay, now let us look at examples and then look at this last question. You can say question number 1. You can say that find the value of k if x minus 2 is a factor of f of x equal to say k x squared plus 4x minus 8. You can do something like this. Yes, find the value of k if x minus 2 is a factor of f of x equal to this. Solution. Now, viewers, look on the board. You see, because we are saying that x minus 2 is a factor, what it means that x minus 2 is equal to 0, x is equal to 2. What it means is that if you have f of x equal to kx squared plus 4x minus 8, f of 2, if it is a factor, then f of 2 should be equal to 0. Yes, when you put 2 here, this one will be 2k times 2 squared plus 4 times 2 minus 8. And we are saying that f of 2 should be equal to 0, so this should be equal to 0. Now, this is equal to, this one will be 4k plus 8 minus 8. Yes, 8 minus 8 is equal to 0. So this means that 4k is equal to, this one will be 0, is equal to 0. So this implies that k is equal to 0. That is 0 over 4. So it means that this k should be equal to 0. And if this k is equal to 0, then this is a factor of this. Yes, then this is a factor of this. In other words, when this k is equal to 0, the whole of this will go to 0. And if you put 2 here, you should get 0. And it will be true. Yes, if you put 2 here, when the whole of this is equal to 0, it's going to be 4 times 2 minus 8. And this will be equal to 0. So this is how, these are some of the questions we can ask you to solve. And let's do another question. We can say that is, you can say this, you can say is x plus 4 a factor of, say, x squared plus 8x plus 16. Yes, you can ask you something like this. If it is a factor, you see it's a factor. So solution. Goes, if it is x plus 4 is equal to 0, so x is equal to negative 4. So you can say let f of x be equal to x squared plus what? 8x plus 16. What this means is that f of negative 4 will be equal to negative 4 all squared plus 8 times negative 4 plus 16. Are you seeing it? And this is equal to negative 4 squared is 16. 8 times negative 4 is negative 32 plus 16. Now 16 plus 16 is 32, minus 32 is 0. So because f of negative 4 is equal to 0, we can say to therefore x plus 4 is a factor. So we can confidently say that this one is a factor of x squared plus 8x plus 16. Yes, because when you put in negative 4, you are able to get what? 0. So it's a factor of it. Are you seeing it? So viewers, it is not difficult at all. It's not difficult at all. Let's quickly look at this question and bring this lecture to an end. Let's quickly look at it and bring this lecture to an end. This question involves both the remainder theorem and the factor theorem. The polynomial f of x, which is equal to x cubed plus ax squared plus bx plus c, is exactly divisible by x plus 2 and x minus 1, but leaves a remainder of 12 when divided by x minus 2. Find a, b, and c. This is a very nice question. Yes, and before you can solve this, you need to understand both the remainder theorem and the factor theorem. Okay, so let's look at it. Solution. Let's look at the question. Solution. The solution to the question. Yes. They have been given this polynomial f of x. F of x is equal to x cubed plus ax squared plus bx plus c. They have been given this. And you are saying that this polynomial is exactly divisible by x plus 2 and x minus 1. In other words, x plus 2 is a factor of this polynomial, and then x minus 1 is also a factor of this polynomial. So let's look at it this way. So x plus 2 is a factor of f of x. It implies by the factor theorem, implies f of negative 2 should give us 0. Yes. Yes, if you have really understood the factor theorem, if x plus 2 is a factor, then f of negative 2, that is x plus 2 equal to 0, x equal to negative 2, f of negative 2 should give us 0. So wherever you see x, you are writing negative 2. So this one is negative 2, all raised to the power 3 plus a negative 2, all raised to the power 2 plus b negative 2 plus c, and this should give us 0. Now, negative 2 raised to the power 3 will be negative 8 plus this one will be 4a minus 2b plus c equal to 0. Are you seeing it? Now, let's rearrange. If you rearrange this one to be 4a minus 2b plus c is equal to 8. Let's call this one equation number 1. Are you seeing it? Now the next one, x minus 1 is a factor of f of x, implies f of 1 should give us 0. So you just go here, wherever you see x, you write 1. So this one will be 1 raised to the power 3, 1 cubed plus a 1 raised to the power 2, then write the a over, plus b 1 plus c, and we are saying that this should give us 0 according to the factor theorem. Yes. Okay, because x minus 1 is equal to 0, x is equal to 1, so this should give us 0. So this one will be 1 plus A plus B plus C is equal to 0. This implies that we are going to have the second equation to be A plus B plus C is equal to -1. So this is equation number 2. Are you finished? And then this same polynomial leaves a remainder of 12 when divided by x minus 2. Are you seeing it? So a remainder of 12 when divided by x minus 2. So this means that f of x leaves a remainder of 12 when divided by x minus 2 implies, okay, so let me finish this one. Implies now, because f of x is leaving a remainder of this, what this means is that f of 2, you should find f of 2, and when you find f of 2, you should equate it to 12, because that one will be the remainder. Do you see? You have given the remainder to us. So when this polynomial, f of x is divided by x minus 2, this is the remainder. So it means that by the remainder theorem, f of 2 should give us 12. So wherever you see x, you write 2. So this one will be 2 raised to the power 3 plus a 2 raised to the power 2 plus b times 2 plus c, and this should give us what? 12. That's the meaning of the question. So this one is 8, 2 raised to the power 3 is 8, plus this 4a plus 2b plus c is equal to 12. Are you seeing it? So this one will be 4a plus 2b plus c is equal to, when 8 goes there, that will be negative. So 12 minus 8, that will be 4. Equation number 3. So viewers, we are going to solve these three equations simultaneously at the same time. Yes, viewers, I have a video on how to use the elimination method to solve simultaneous equations. I also have a video on how to use the substitution method to solve simultaneous equations. Okay, so we are going to solve these three equations simultaneously. Yes, so let me just clean this and write the most important equations. So we have 4a minus 2b plus c is equal to 8. This is equation number 1, isn't it? And then we have a plus b plus c is equal to -1. Equation number 2. Let's write the equations and take our time to solve. Yes, them simultaneously. 4a plus 2b plus c is equal to 4. Equation number 3. Okay, so let me just clean all this. Now viewers, look on the board. We have three equations to solve simultaneously at the same time. Now this is what we are going to do. This is what we are going to do. We are going to subtract. You can decide to subtract equation 2 from equation 1. Now look at it. 4a minus 2b plus c equal to 8. A plus b plus c equal to -1. If you subtract equation 2 from equation 1, you see c will cancel c. C minus c to go to 0. Isn't it? And then when you finish, you can subtract equation 2 from equation 3. And when you do that, c will also go. Do you see it? So let's do it this way. So you can say equation 1, you have to circle the equations, minus equation 2 implies, yes, you are subtracting equation 2 from equation 1. 4a minus, is this 4a in equation 1? 4a minus a will be 3a. Negative 2b minus b will be negative 3b. C minus c will be 0. 8 minus, here in the formula, minus 1, that will be 9. Alright, so let's call this one. You can work on this. Here you can decide to divide through by by 3. Divide 2 by 3, that would be a minus b is equal to 3. Let's call this one equation number 4. Now, equation 3 minus equation 2. You see, equation 1 minus equation 2 has given us this. And if you look at this one, you see that we have only two variables, a and b. So let's look at what equation 3 minus 2 also gives us. Equation 3 minus 2, 4a minus a, 3a. Are you seeing it? 2b in equation 3 minus b in equation 2. That will be b. C minus c, 0. 4 minus 1, that will be 5. You have to be very careful. And this is equation number 5. Are you seeing it? Yes, so we have a minus b equal to 3, and then 3a plus b equal to this. Viewers, from equations 4 and 5, if you look at the two equations critically, you can see that if you add the two equations, the b will vanish. When the b vanishes, you can solve for a and then put it in 4 or 5 to get a. And when you get a, you can put it in any of these three equations to get the c. Are you seeing it? So let's do it. You can say equation 4 plus equation 5. So when you do that, this one will be 4a plus 3a, that is 4a. So equation 4 plus 5 implies, so this will be 4a. Now negative b plus b will go to 0. And this is equal to 3 plus 5, 8. So a is equal to 8 over 4, and this is equal to 2. Now if a is equal to 2, you can say that from equation 4, from 4, a minus b is equal to 3. So a is now 2, so 2 minus b is equal to 3. Are you seeing it? So you can say 2 minus 3 is equal to b. This one will go here, be positive, and then this one will come here, negative. So it means that b is equal to negative 1. Are you seeing it? Now, so we now know the values of a and b. We can put these values in any of these three equations. So let's take the simplest one. Yes, let's take the simplest one. So you can say from equation 2, a plus b plus c is equal to negative 1. Now our a is 2 plus our b, the b is negative 1, plus c is equal to negative 1. 2 plus negative 1 will be 1, plus c is equal to negative 1. So our c is equal to negative 1 minus 1. So c is equal to negative 2. Are you seeing it? So therefore, a is equal to 2, b is equal to negative 1, and c is equal to negative 2. Are you seeing it? So these are the values of a, b, and c, and these were the values they asked us to find. Yes, so that will mean that the function will now be f of x is equal to s cubed. You have seen a plus 2s squared. I've seen b, so minus x minus 2. So this will be the polynomial. Yes, the polynomial function. Are you seeing it? So viewers, you have seen that the remainder and the factor theorems are very, very important, and they are easy to understand. Thank you very much for your attention. For more of this video, subscribe to my YouTube channel, Shamalaa Jnr.